Oh, we are absolutely crushing some trigonometry. And today we're going to focus on just the graph of the cosine function. Now, I will add this. I think there's a lot of overlap and a lot of similarities between the cosine function and the sine function. And I made the sine function video first. So if you haven't seen that one, I'd encourage you to check that one out first, because a lot of the things I'm going to try to go a little bit faster over any of the repetition and repeated concepts we're going to see here in the cosine function today. So without watching that sine video, this one could be extra confusing. So again, what are our goals today? At the end of the video, we're hoping that we could look at an equation like this and without doing any fancy work, identify amplitude, frequency, and period. And we're also thinking we're going to be able to graph this function completely by hand over the interval negative 2 pi to 2 pi. So those are our big goals today. Again, we're going to rely on our unit circle to get the party started. Today, it's all about the x coordinates. So we're going to take these x coordinates and just transfer them over to our table of values. And it's just a little different way of reorganizing this information so we don't have any extraneous numbers in front of us. And so let's see here. Let's see, I think pink works good here. So the cosine of 0 is 1, and then it goes radical 3 over 2, radical 2 over 2, 1/2, 0. So there's an x-intercept right there. And just remember, ballparking, that's about 0.866, 0.770, I believe, and of course 0.5 to ballpark those decimal values. Then we're going to go negative 1/2, negative radical 2 over 2, negative radical 3 over 2, negative 1. That's the bottoming out point. And we start to turn and come back up a little bit. You see the repetitive nature and the predictability of this graph. There's an x-intercept. Continue to climb, continue to climb. And then at 2 pi, we'll finish back at 1. So I'm going to try to plot those points as carefully as I can here. So we're going to start at 1, and then we're going to go do. All right, and then we're going to be about right here. Here. All right. Okay, not too shabby, not too shabby. So that's one complete cycle. And a couple of things we'll note here. The function is decreasing, we'll say from 0 to pi. So if I was to highlight that section from here to here, the function's decreasing. And then we could say the function's increasing from pi to 2 pi. So that would look like this section right here is increasing. Now, another concept that I want to introduce you to here, and hopefully this doesn't get too crazy, is, when is the function concave down versus concave up? Now, concave up, I'll abbreviate CCU, is going to be from pi over 2 to 3 pi over 2. And whenever we say concave up, I want you to think smiley face. Like, what portion of the graph looks like a smiley face? And that would be from here to here. All right. And then the opposite of being concave up is to be concave down. And I'll abbreviate that CCD. And that's first the interval from 0 to pi over 2. That's like kind of half of a frown. And then the second interval would be from 3 pi over 2 to 2 pi. And that's the second half of a frown. So thinking of it in terms of a frown, let's say we're concave down from here to here, and then again from here to here. So not only do we focus on, the behaviors of increasing and decreasing, but if you can start to think about the concavity of this graph, that's going to carry you a long ways to making some really, really nice drawings here today. Now, I still want to talk about the left-hand side, and the values are going to look like this. Let's see if I can get these drawn. So you'll see today's function is symmetric with respect to the y-axis. And of course, maybe we'll put arrows on the end of this graph for emphasis, and it's just going to turn down and repeat. It's going to turn down and repeat. And you could, in theory, I think, usually we only go from 0 to 2 pi, because once you see that, you've seen it all. And if you had to go to 10 pi, you could. If you had to go 0 to 800 pi, you could, because of that repetitive nature. Again, just like the sine curve, the domain is from negative infinity to positive infinity. The range is from -1 to 1 inclusive. The graph never rises above 1. It never falls below -1. The period is 2 pi. After that, it just repeats another cycle. Here's one noteworthy change. Instead of being an odd function, this function is even. And the definition of an even function was that f of -x equals f of x itself. And this could be observed by seeing the graph is symmetric with respect to the y-axis. All right, we have the same definitions of amplitude, frequency, and period that we saw in the last graph. Again, the period is going to be the number of radians from a starting point to when it, closes that cycle and starts to repeat itself. So I think we can blow through those. This is doesn't matter whether we write sine here or cosine. Everything is still the same. A is going to be your amplitude. B is your frequency. Same definitions below that. Amplitude is the absolute value of A. Period is 2 pi divided by your frequency. So let's try a couple, shall we? Amplitude is going to be the absolute value of 3. Your frequency is going to be the coefficient of x. And the period is going to be 2 pi divided by your frequency. In this case, it reduces to pi. Amplitude is going to be the absolute value of -5, which makes 5. Frequency is going to be a very tough 3, which makes the period 2 pi divided by that 3. That's a tough one to graph. Your amplitude is going to be the absolute value of -4. Frequency is going to be 1/4. Interpreting that, it says you're only going to see 1/4 of your cycle at 2 pi. So from 0 to 2 pi, you're only going to see a quarter of a circle. That's that first little half hump. And the period is 2 pi divided by that 1/4, which by the time you simplify it, comes out to be 8 pi. So you won't complete that first cycle until you get all the way out to 8 pi. Wowzers. Okay, so what we have here is a picture of the original generic cosine function with an amplitude of 1. And all we want to do is try to graph 2 cosine. So now you've got an amplitude of 2, a frequency of 1, and a period of 2 pi. So all we're going to do is we're going to make it a little taller, still crossing at pi over 2. We're going to dip down here, still cross here, and get up to this point right here. So we're going to be concave down. I don't know why tilting my head seems to help. Oh, I over-embellished this. Oh, I don't like that at all. Let me redo that. I'm sorry. I don't mean to make this video last longer than it has to, but sometimes when I go right to left, okay, that's a little better. And then you'd see something really similar on the back end here. And we're just making everything a little taller, a little deeper. All right, so that's 2 cosine of theta. What if we changed the amplitude and we shrunk it down a little bit? What if we only did 1/2, but we still had a frequency of 1 and a period of 2 pi? So again, the only thing we're changing or manipulating is the height of the function. So now we're going here to here to here to here. Notice we have the exact same x-intercepts. So the concavity here is going to be really subtle. We don't want to make sure we don't have straight lines, that's for sure. We're going to be concave down, switch concave up. Boom. Okay, not too bad, not too bad. I've drawn worse, that's for sure. Okay, so now we're going to start to manipulate the frequency, and here's where I think it gets a lot more challenging. Good news is we've got an amplitude of 1, frequency is now 2. So we're going to finish 2 cycles at 2 pi, if you want to make a note. And then the period is going to be 2 pi divided by 2. So we're going to finish our first cycle at pi. Now, so what I'm thinking, if I'm going to start at 0, and I know I've got to start here, and I'm going to finish a cycle at pi. Working from the outside in, I know that halfway between those points is going to be my relative min. And halfway between this max and this min is going to be my x-intercept. And again, right here. So there's 1 cycle. If I was to repeat that process all over again, working from the outside in, knowing you can figure out where your x-intercepts have to be. We want to make sure we don't make our lines too straight, but we don't want to make them, we don't want to go overboard and like over embellish the curvature to the point where it's too roly-poly. Really want to protect the integrity of this graph the best that we can. And this would be a fun one to talk about if we had to talk about, when it's increasing and decreasing. But if nothing else, I think you can take pride in your artistic skills, and they sure make some nice pictures when we're all said and done. Ooh, what if the amplitude stays 1, but now the frequency goes to 1/2, right? And that makes the period 4 pi. So let's say we know from 0 to 2 pi, we're only going to see half a cycle. We know we're going to start here. We're going to cross at pi, and then we're going to dip down. So we're going to be concave down first, switching the concavity at pi. Oops, I maybe got to drop down a little bit lower. There we go. Okay, and then we're going to crisscross here. We're going to go here to here. And again, we can always check these on our calculator, but it feels so good to do these by hand. I think it's a very rewarding process. And I think really what we're trying to do is we're trying to prepare. You're like, why would I even waste time doing them by hand, right? Well, as we prepare ourselves for higher levels of math, being able to sketch a function like this one right here real quick, like 10 seconds or less, being able to sketch this function, it doesn't have to be anything super fancy. We just sketch it, can really help us solve some really big time calculus problems and so forth. Frequency is going to be a 4, period is going to be a pi over 2. And again, that negative just reflects what I would normally have over the x-axis. So instead of starting at the peak, we're going to start down in a valley and work our way back up to the x-axis. So, and I got to finish at pi over 2. That's going to be a challenge. Okay, let's make sure. So I'm going to start all the way down here, and I'm going to finish that cycle at pi over 2. So halfway is going to be my max, and I'm going to cross here. All right. This is going to be tight. It's going to be real tight. All right. And I'm just going to try to repeat that process. I was thinking about, hitting the pause button and trying to save some time, but I think it's worthwhile to see, how I plot these points. Figured it can't hurt. Shucks, the intervals are so tight that I'm not making them as smooth as I'd like. Let's see what we got cooking here. Yeah, I'm going to give myself like a C- on this, but you'll see I do have the 4 cycles, between the interval 0 to 2 pi, and of course we could repeat that process on the left side of the y-axis, just reflect everything over. Let's see, I think we got one more example in the hopper, and so we're seeing now we've got an amplitude of about 1.5. We've got that tough frequency of 3, and that makes the period 2 pi over 3. And we're going to have to do a lot of estimating and eyeballing as to where that 2 pi over 3 falls. So that 2 pi over 3 is going to put us about right here. What I'm really trying to do is I'm trying to take each interval, whether it's 0 to pi over 2 or pi over 2 to pi, and I'm trying to visually break those intervals into thirds. Okay, so if I broke everything into thirds, I'd have a third here, a third here, here. And those are like my 4 key intervals here. Cosine is going to start up here. It's going to cross. It's going to dip. It's going to cross. And it's going to peak. So if I can connect those. Oh, I missed it. Oh, man, I hate to erase that. Okay, I think the root of my problem was I put the min in the wrong. I got to slide it over here. Okay, let's see how this helps. Okay, a little bit better. But let's say we continue to break everything into thirds. So we got a third there, a third there. We're going to be right there, right there. Okay, so this right here is your 4 pi over 3. That's where you're going to finish that second cycle. So we're going to start up here, cross here, bottom out at pi, cross, and then peak right here. Again, here's what you got to make sure. You got to make sure when we're all said and done, you've got 3 equally spaced cycles. Okay, So we're going to start up here, cross here, bottom out here, cross here, and then finish up here. Whew. So there's 3 cycles. I finished the first purple one at 2 pi over 3. I finished the pink one at 4 pi over 3. And then I finished the green one at 2 pi. And again, we could reflect everything over the y-axis and repeat everything on that side if we had to. So thanks for hanging in there with me today. And I hope you feel pretty good about this one.